Probability is nothing but measuring any event which is unpredictable. Whatever the results you will be having for a particular experiment, those are called as outcomes of an experiment. When you write all the outcomes in the form of a set, this is what you will get. That is the sample space of an experiment. If the coin shows head, you have to roll a die. So when you roll a die, you are getting the chances of getting 1, 2, 3, 4, 5, 6. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are at the last chapter of your first PUC syllabus, that is the chapter probability. So in today's session, we will be discussing what do you mean by probability and the terms related to it. So especially the random experiment and sample space of a experiment. Now, what do you mean by probability? So in your secondary classes, especially in your class 9, you have studied the probability of a event is nothing but measuring of uncertainty or measuring of an event happening. Usually, probability is nothing but the measure of uncertainty of a various phenomena. Probability is nothing but measuring any event which is unpredictable. So, which can be predicted in somehow percentage. For example, it may rain today. I may get 100 out of 100 in the examination. All these are all prediction. So, wherever you will apply the concept of prediction and measuring those predictions, that is measuring of uncertainty, is nothing but the probability. It's a numerical measurement to measure the uncertain events, we can say. Next, it is the ratio of the number of outcomes of favorable to the total number of outcome. This is what actually you have studied in your class 9 and it is called as classical approach of probability. That means, for example, when you throw a die, so you have 6 results. That is, you may get 1, 2, 3, 4, 5, 6. Like this, you will get 6 results. So, what is the necessity or probability of getting only even number? You have only 3 chances out of 6 chances. That's why you will write in the form of 3 by 6. So, that is exactly half chance to get even number. Similarly, half chance to get a odd number. For example, one more experiment, that is tossing a coin. When you toss a coin, you can calculate the chances of getting head as well as the chances of getting tail. When you throw a coin in a single turn, then you have 50% chance of getting head, that is 50% chance of getting tail. That is, when you compare it into fraction, it is nothing but 1 by 2. Like this, you have calculated the probability from the classical approach by the total number of outcomes favorable to the event to the total number of outcomes. That is, usually you might have denoted it as in the form of probability of A as number of favorable outcomes to total number of outcomes. So this is what actually you have calculated. Let me give you one more example. So let me consider a bag. A bag contains one red ball, one black ball, one green ball. So you want to take one ball from the bag. What is the chances of getting red ball? So total number of balls here is 3 and number of favorable outcome, that is chances of getting red ball, is only 1. So therefore, the probability of this experiment is 1 by 3. Like that, if you take it for blue ball also, it is 1 by 3. For green ball also, it is 1 by 3. So based on the favorable outcomes, when it is in the form of a ratio of number of favorable outcomes to the total number of outcomes, that will give you the probability value, which is called as the classical approach to probability. Now let's see the related terms belonging to the probability. So the very first one you must know is random experiment. In our daily life, we may come across many activities where you will get the result exactly the same what you accept. How many times you repeat it, it will be the same. We may come across more experiment where the result may vary. So, what type of experiments they are called? They are called as random experiment. Then what do you mean by random experiment? A random experiment is an experiment where it has more than one possible outcome. For example, tossing a coin. You cannot predict exactly you will get head or exactly you will get tail. You are predicting only the chances. So, wherever the experiment has more than one output or called as outcomes, when experiment has more than one outcomes, they are called as random experiment. The second thing is, it is not possible to predict outcomes in advance. As I said, when you toss a coin, you cannot predict whether you will get exactly tail or exactly head. You can just say chances. You might get head now, you might get tail now. So that is for an experiment where you cannot predict the outcome and also the outcome is more than one outcomes, those experiment are called as random experiment. We can also take an example of throwing a die. So throwing a die is also example. So when you throw a die, you will get the outcomes as 1, 2, 3, 4, 5, 6. So these are the outcomes you will get when you throw a die. You cannot predict exactly you will get 3, exactly you will get 4, exactly you will get 1, like that. So it has more than one outcome and you cannot predict the outcomes. So such type of an experiments are called as random experiments. The next thing is outcomes. So what do you mean by outcomes? Outcomes are nothing but the results of a random experiment. So let us take an example of tossing a coin. If you take an example of tossing a coin, you have two results. One is you get head, another one is you get tail. So throwing a dice. So 1, 2, 3, 4, 5, 6. So these are the outcomes of the given experiment. Let me take one more example, tossing 2 coins at a time. That is tossing 2 coins at a time. So when you toss 2 coins at a time, what are the results you may get? Both have heads, one head, second tail, first tail, second one head, or both have tails. So these are the possible results of an experiment which are called as outcomes of the random experiment. So whatever the results you will be having for a particular experiment, those are called as outcomes of an experiment. Next one is very important, that is sample space of an experiment. What do you mean by sample space of experiment? It is the set of all outcomes of a random experiment. So for example, I said, so the possible result of a random experiment. I have given an example of tossing a coin. H is one output, T is one output. If you write it in the form of a set, denoting with the letter S, this is the sample space of an experiment. That is, writing all the possible outcomes of a random experiment is nothing but a sample space. So let us take an example of throwing a die. Then I can write it as 1, 2, 3, 4, 5, 6. So this is an example of writing a sample space. Tossing 2 coins may be written as H, 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 T, T, H, T, T. So these are the outcomes which you will write in the form of a set, that is called as sample space, and the elements inside it are called as sample points. For example, HH is a sample point, HT is a sample point, TT is a sample point. Here 2 is a sample point, 3 is a sample point, 6 is a sample point. So all the outcomes of an experiment is written in the form of a set, which set is called as the sample space of an experiment, and the elements inside it is called as the sample points. Now, let me take one more example here. Consider I have 1 rupee coin, I have 2 rupees coin, and I have 5 rupees coin in a pocket. have to take 2 coins at a time. 2 coins at a time. So what are the chances of taking 2 coins from the packet? So that is, let me name this as P. Let me name this as Q. Let me name this as R. I am naming 1 rupee coin as P, 2 rupees coin as Q, 5 rupees coin as R. Then what are the outcomes of this experiment? What are the possible results of this experiment when you take 2 coins from a pocket? That is, the first one is you can take in the combination of PQ. That is, the coins taken may be 1 rupee or 2 rupee. Or it may be like this. It may be 1 rupee or 5 rupees. Similarly, the chances is first you might take 2 rupees, that is Q. Then you have taken R. Or first you have taken 2 rupees. Then you have taken 1 rupee. One more chance is first one you might taken 5 rupees. Then you have taken 2 rupees. Or first one you have taken 5 rupees. Later you have taken 1 rupee. So these are the possible chances of or the results of a given experiment. That is, when you're taking 2 coins from a pocket one after the other, the chances or the results of an experiment will be like this. So when you write all the outcomes in the form of a set, this is what you will get. That is the sample space of an experiment. Look at the first question we have. Write the sample space for the following random experiment. The very first one is 2 coins are tossed. We have already written this. Whenever 2 coins are tossed at a time, both coin may have head. One head, one tail, one tail, one head, or both of them are tails. So these are the possible outcomes of a given experiment. Let me take the second one. Find the sample space of rolling a pair of dice. So we have 2 dice here. So what are the chances of getting the output? So the thing is, both can have 1, 1, 1, 2. So suppose you have 2 dice here. One more dice. The face may be 1, 1. Or here 1, here 2, or here 1, here 3, like this. The face may get different numbers. So what are the possibilities I can take here is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So fix the first one, just rearrange the other dice. So you may get the chances of getting 1 in the first die, 2, 3, 4, 5, 6 in the second die. The same thing can happen if first dice can have 2, then it might have 1. Similarly, from 2, 1, 2, it might have 2, 2, or 2, 3, or 2, 4, or 2, 5, 2, 6. Similarly, it can happen for 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. The same thing can happen when the first die have 4, the second might have 1 or 2 or 3 or 4 or 5 or 6. And it will be same for 5, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And the same thing can happen whenever the first die shows 6. The second die may show 2 or 3 or 4 or 5 or 6. So I am writing it in the form of a set. So I am using it in the flower brackets here. So the element must be written in the flower brackets so that it will represent a set. So let's take one more example. A coin is tossed and a dice is rolled. So here we have a coin. It may have 2 possibilities. One, it might get head. Another one is it might get tail. The next thing is, so it's a dice. It can show 1 or 2 or 3 or 4 or 5 or 6. So if you think this is the face of a die, then it might have shown any number from 1 to 6. Now let's write what are the possibilities or what are the results of a given experiment. If coin shows head, it might show 1, or if coin shows head, it might show 2. Like this, you will have H4, H5, H6. Similarly, if you have tail, if the coin shows tail, the chances here it might be T1, T2, T3, T4, T5, T6. So these are the possible outcomes of a given experiment. The next one is a coin tossed 3 times. So remember, coin tossed 3 times or 3 coins tossed at the same time is nothing but 1. So here a coin tossed 3 times must be taken as 1 trial. So therefore, if you toss a coin 3 times, all the 3 times you might get head. First 2 times head, the next time tail, or all the 3 times you might get tail. Like this, what are the possibilities you can get for this experiment? Let us see now. So let me write the sample space S is equal to, so all the 3 times if you get, you can write it as HHH, or you might get it as HHT, HTH, THH, or TTH, THT, HTT, TTT. So look here, these are the possibilities you can get when you toss a coin 3 times. So this is same for tossing 3 coins at a time. So a coin is tossed 3 times is equivalent to tossing 3 coins at a time. So the sample space for both the experiment is same. So here you are repeating the same coin 3 times. Here you are taking 3 coins at a time. So the possibility is one and the same. So you can get 3 heads at each time, or the 3 coins can get head, head, head at same time. So this is one and the same. So for these 2 experiments, the sample spaces HHH, HHT, HTH, THH, TTH, THT, HTT, TTT. Let's see the next one. A coin tossed 4 times. A coin is tossed 4 times. All the 4 times it might get head. First 2 head, next 2 tails, all are tail. First 3 tails, 1 head. Like this, let us write what the possibilities here. So we have S. Let us write all the 4 gets head. So the next thing is, first 3 times you might get head, the last one may be tail. Like this, you can write H, H, T, H, H, T, H, H, T, H, H, H. So or else 2 times tails, 2 times head possibilities. So head, head, tail, tail, head, tail, tail, head. Next, tail, tail, head, head, tail, head, head, tail. So this is another possibility. Let's take tails 3 times now. So you might get H, T, 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 or T, H, T, T, or T, T, H, T, or T, 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 H. The last one is all might get tails. So these are the possible results which you can get when you toss a coin 4 times. And this sample space is equivalent to tossing 4 coins. So the sample space for this experiment is also same. Let's see the next one. 2 boys, 2 girls are in room X. 1 boy, 3 girls are in room Y. Specify the sample space for the experiment in which a room is selected and then a person. Let's look at the options we have. So we have room X and room Y. So we have 2 girls and 2 boys. So let me take it as G1, G2, boy 1, boy 2. So these belongs to room X. So we have 3 girls. Let me write it as G3, G4, G5. Girls and 1 boy. B1, B2 is null. Let me write it as B3. So these are the number of boys and girls which are in room X and room Y. So we are supposed to write the sample space where the room is selected first and then the person. So if in that case the sample space is, it is XG1 or XG2 or XB1 or XB2. If not in the room X, then the only possibilities is room Y, it is girl 3, room Y, girl 4, room Y, girl 5, room Y, boy 3. So these are the possibilities of selecting room first and then the person. Next one. 1 dice of red color, 1 of white color and 1 of blue color are placed in a bag. 1 die is selected at a random and rolled. Its color and the number on its uppermost face is noted. Describe the sample space. Let me take, so this is a red one and next we have white one. So this is white one and the next one is, so this is blue one. So we have to take a die and roll. So the die rolled, whenever you take any one of the die, first the color is noted, then the number is noted. So what are the chances or what are the sample points of this experiment? So we will write it as, so you might choose red. The uppermost face may show 1. Similarly, you might choose red which shows 2. Like this, R3, R4, R5, R6. So these are the results when you take red die. Similarly, when you take white die, it is W1, W2, W3, W4, W5, W6. So if you take for blue 1, it may show blue 1, blue 2, blue 3, blue 4, blue 5, blue 6. So these are the number of sample points inside the set. So this is the sample space of a given experiment. Let's see the next one. An experiment consists of recording boy-girl composition of a family with 2 children. What is the sample space if we are interested in knowing whether it is a boy-girl in the order of their birth? What is the sample space if we are interested in the number of girls in the family? A family must consist of 2 children. We have to write the order of the boy-girl combination for the first one. So if it is suppose like that, then what is the sample space for this experiment? That is, what is the sample space if we are interested in knowing the boy or girl as a combination of in their order of their birth. So let us write the sample space for the first one. S is equal to, the 2 children can become boy, or the first one may be boy, the second one is girl, or first is girl, second is boy, or both are girls. So these are the combinations of 2 children. The second one says, what is the sample space if we are interested in the number of girls? All the possibilities is, the sample space can have 0. There might be no girls, or there is only 1 girl, or there are 2 girls. So if you look at the sample space of the first one, if 2 children are boys, then there is no girl. If it's a combination of boy, girl or girl B, the chances is only 1 for a girl. If 2 of them are also girl, then we can count the number of girls as 2. So this is the sample space for the second one. Next one, a box contains 1 red and 3 identical white balls. 2 balls are drawn at random in succession without replacement. Write the sample space for this experiment. So here we have a bag. We have 1 red and 3 white balls. So you want to take 2 balls from the bag. So what are the chances? First you have taken red, or second you have taken white. Or first you can take white, the next is R. that is red. Or first also you have taken white ball, second also you might have taken white ball. So these are the only possibilities here. So therefore the sample space of an experiment is RW, WR, WW. Next one. Suppose 3 bulbs are selected at random from a lot. Each bulb is tested and classified as defective or non-defective. Write the sample space of this experiment. So let us consider here we have 3 bulbs. So we are tested all 3 bulbs and they are good, we write it as non-defective. If they are not good, we write it as defective. So what are the chances? That is, all the 3 might have non-defective or all the 3 are defective. First 2 defective, the last one non-defective. First 2 non-defective, the last one defective. Like this, let us see what is the sample space we can write. So all are defective means we will write it as D, D, D. First 2 defective, the last one non-defective, or D, N, D, or N, D, D. Similarly, we can write N, N, D, N, D, N, D, N, N, and all are non-defective N, N, N. So these are the only possibilities you can get for this experiment. Next one. A coin is tossed. If the outcome is head, a die is thrown. If die shows up an even number, the die is thrown again. What is the sample space of the experiment? Remember, here we have a coin. So we have 2 outputs, that is, it might get head or it might get tails. So if it gets heads, a die is thrown. So a die is thrown here. So we can write the sample space with the combination of head. If it is even, it is again thrown. Then we have to write the possibilities. If it shows tail, we can stop there only. So let us see the possibilities of experiment. So the sample space is, if a coin tossed get tail, we can stop the experiment. If it shows head, we will roll a die. Then what are the combination? H1, H2, H3, H4, H5, H6. So these are the combination. So again they have given the condition, if when a die is rolled, if you get an even number, where are the chances you are getting even number? 2, 4, 6. So anywhere if you get an even number, you should repeat the experiment again. What are the chances you can get there? So that is H2, 1, H2, 2, H2, 3, H2, 4. Next it might be H2, 5, H2, 6. Similarly, you can get H4, 1, H4, 2, H4, 3, H4, 4, H4, 5, H4, 6. Similarly, for 6, it is H6, 1, H6, 2, H6, 3, H6, 4, H6, 5, H6, 6. So these are the possibilities or the results of an experiment. That is, if the coin shows head, you have to roll a die. So when you roll a die, you are getting the chances of getting 1, 2, 3, 4, 5, 6. So after getting whether it is 1, 2, 3, 4, 5, 6, if again it is an even number, the die or the experiment is repeated again. So then what is the combination? Then it is H21, H22, H26, H412, H46. Similarly, H612, H66. So these are the combinations you can get. Suppose if you get tail, you can stop the experiment. So I have written that also in the first outcome. Next one, numbers 1, 2, 3 and 4 are written separate from 4 slips of paper. The slips are put it in the box and mix it thoroughly. A person draw 2 slips from the box one after the other without replacement. Write the sample space of the experiment. So what are the possibilities I can get? I can get 1, 2, 1, 3, 1, 4. Similarly, I can get 2, 1, 2, 3, 2, 4. Similarly, I can get 3, 1, 3, 2, 3, 4. Or I can get 4, 1, 4, 2, 4, 3. So these are the combination where I can pick 2 slips from the box. So we have 12 combinations here. So like this, you can write the sample space of any experiment based on the given condition. So I hope you understood clearly about the random experiment and how to write the sample space of a given experiment. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.